This question is from one of the interesting books and has a very unique solution. I encourage each one of you to pause this video and try this question on your own. This question states that there is a man who is at A and wants to reach C, and C is downstream from B, which means river is flowing in this particular direction. This is the direction of the river velocity. Now a man in the boat, he starts from A and wants to reach C, and that is what it is given. The width is also given to you, which is B, and you have to find minimum speed of the boat and related to the water current, and also the direction in which it must be steered. So the solution is pretty simple. The first solution which directly comes to mind is the conventional method, and conventional method is usually the calculus method, because whenever minimum maximum has to be found, it actually leads to it is solved by calculus. So calculus says the direction of the resultant is constant, because if a boat has to reach to this particular point, it will always, the resultant will point in this particular direction. So this is constant, and this tan alpha is clearly B by C. So if it is B by A, this is A and this is B, so tan alpha, which is the direction of the resultant, it's not where it has to be steered, we will have to find out that it is B by A, and then you will apply calculus and solve it. The another method is a vector method, and I encourage each one of you to think it that way. So let's say if this is the resultant direction and this is the direction of the river, okay, this is the resultant direction. Now man can steer in this direction, man can steer in this direction, man can steer in this direction, and you can clearly see that it will be minimum when the man direction will be perpendicular to the river direction. So if this is the resultant direction and if man is perpendicular to this, so velocity of the river plus velocity of the man or velocity of the boat with respect to the river, this has to be perpendicular to this. And whenever it is perpendicular, because if vector is not perpendicular, its magnitude will be always greater than, it is minimum when it is perpendicular to the resultant direction. So clearly now you get the answer, because directly you will see that this is alpha, and velocity of the boat with respect to the river is nothing but it is velocity of the river. This is resultant velocity, so sine of alpha, and tan alpha we have already calculated B by A. So sine of alpha will be equal to VR B upon under root of B square plus A square. So this is simply velocity of the boat with respect to the river, and let me just correct it, it is B square. Okay, so this you directly will get the answer. And the second thing that you have to find is the angle. So angle, so now it is becomes very easy, because this is alpha, this is 90 minus alpha, so this will also be equal to alpha only, and therefore it will also move in the direction of alpha, and alpha we had already calculated, it is tan inverse of B by A. So it has to steer in the direction of alpha from the vertical, and that alpha is nothing but tan inverse of B by A. So we have got both the answers here just by looking at it and visualizing it through vector. And one question similar to this I have already solved in level up series, which was for the conveyor belt, and you should look at both the questions, which is very similar solution. So see students, it's very important for all of us to understand that there lies beauty in physics, because one concept which we have studied earlier can be applied in a lot of places wherever vector is applied. So we have to keep in mind, if minimum speed is asked, then we have to look at the vector and we have to see if it is making any sense, what is given in the question, how to approach in that question. That's all we have to keep looking at while trying to prepare for very high level Olympiad physics or very high level advanced physics. So all the best for all those who are preparing. I hope you like the solution. Please give me a thumbs up if you like the solution, and for more kind of these questions, subscribe the channel and share it with as many friends as possible. Okay, thank you. Bye bye, take care.